Phone calls cost Y pound for X minutes. The graph gives the values of Y for values of X from 0 to 5. Give an interpretation of the intercept of the graph on the y-axis. So the intercept means where it crosses, and the graph on the y-axis. So the y-axis is this one here. What does it mean that it crosses here? What does that mean? Well, if we're thinking about the fact that every time we go across one, that's another minute on the phone, and across another one is another minute on the phone, we can see that the longer we're on the phone, the more we're paying. This value here represents the fixed charge. So this represents the fixed cost, and it's the amount that you pay for not being on the phone. So amount you pay as the phone call starts. Basically, it's going to cost you that much, and then the price is going to go up from there. So that's the fixed cost. It's the amount that you pay before that phone call has begun. Give an interpretation of the gradient. Well, we can see that every time it goes across 1, so from here, if we go across 1, it's gone up from 50p up to £2. So we can see it's going up by £1.50 every time it goes across 1. And what that means, the actual gradient, means the cost per minute for being on the phone. And we can see, minute for being on the phone. Find the equation of the straight line. Now the equation of a straight line is y equals mx plus c, where m is your gradient, that's how steep it is, and c is your y-intercept. So the gradient, we know, for every time we go across 1, it goes up by 1.5. And we know that the y-intercept, c, here, was at 0.5. We can see that from the graph. So the equation of my line is y equals 1.5x add 0.5. On Monday, Tarek travelled by train from Manchester to London. Tarek's train left Manchester at 8:35. It got to London at 11:05. The train travelled at an average speed of 110 miles per hour. On Wednesday, Jill travelled by train from Manchester to London. Jill's train also left at 8:35, but it was diverted. It had to travel an extra 37 miles, and the train got to London at 11:35. What's the difference between the two trains' speed? So the first thing we're going to want to do is draw our triangle: speed, distance, time. Okay, if we want the distance, we do speed times time. If we want the time, it's distance divided by speed. And if we want the speed, it's distance divided by time. So in this case, we're going to want the speed. Now, Tarek's train left Manchester at 8:35 and it got to London at 11:05. So for Tarek, let me do it this way, 8:35 to 11:05, 9:35, 10:35, 11:35. So it's going to be 2.5 hours. Okay, 1 hour is 9:35, another hour is 10:35. And then we've got another half an hour, so 2.5 hours. It travelled at an average speed of 110 miles an hour. So they've given us the speed and they've given us the time. And so we can work out the distance. The distance from Manchester to London is going to be 2.5 times by 110. Now remember, I've written 2.5 here. I know it's 2 hours 30, but 2.3 is not the same as 2.5 hours, so we need to say 2.5. Okay, 1 hour, 110, and another 110, and then 55. So that's timesing it by 2.5, timesing it by 1, timesing it by 1, timesing it by a half, and that gives us 275 miles. So we now know that it's 275 miles from Manchester to London. Now let's look at Jill. She's going the same route, Manchester to London, but her train is an extra 37 miles. So for Jill, she's going 275, add an extra 37, which is 312 miles. So her journey is longer. She got to London at 11:35, 8:35, 9:35, 10:35, so 3 hours. So then we know to get her speed, we need to do distance divided by time, and the distance is 312 divided by the time, which is 3 hours. 3 into 3 goes once, 3 into 1 doesn't go, carry it over, and 3 into 12 goes 4 times. So Jill was going 104 miles per hour. Tarek was going 110 miles per hour. And so my final answer, which was the difference between their speeds, would be 6 miles per hour. 110 take away 104. Okay, on Monday, Ria delivered a parcel to a hospital. The travel graph represents Ria's journey to the hospital. We're told that she left home at 1 o'clock, so I've gone ahead and put that time in there. And we're also told that she drove for 30 minutes at a constant speed of 40 miles per hour. Now, if this is 30 minutes, I've gone ahead and put 1:30 here, then 2, 2:30, 3, 3:34, and 4:30 and 5. She drove for 30 minutes at a constant speed of 40 miles per hour. Now, if she was going for 30 minutes at 40 miles per hour, in 30 minutes, if it's 40 miles per hour, in half an hour, she only would have got 20 miles. So I know then that this distance here is 20 miles per hour, and that enables me to mark out the rest. I've got 10 there, 30 there, and 40 there, and so on. She drove to the hospital at a constant speed. She was at the hospital for 30 minutes, so we need to come across 30 minutes there. Should definitely be using a ruler. Please use a ruler if you have one. And then she drove home at a constant speed of 32 miles per hour. Show that she does not arrive home before 4:30. Now, she is currently at the hospital at 3:30. So leaves hospital at 3:30. My word, sorry, long day. 15:30, there we go. She leaves the hospital at 3:30, and it's going to take her an hour if she needs to get home by 4:30. Now, she has 40 miles to travel. If she's going 32 miles per hour, she's not going to cover that 40 miles in enough time. So she would need to be going 40 miles per hour to travel 40 miles in an hour. She would not be able to get home doing 32 miles per hour. She's only going to be able to go 32 miles in an hour if she's travelling 32 miles an hour, and therefore she will get back after 4:30. So no good. Shape A is translated by the vector 4 minus 7 to make shape B. Now our top numbers left and right, bottom numbers up and down. You might find it helpful to remember by doing this. This is positive and this is negative, just like coordinates. And up is positive and down is negative, just like coordinates. And then shape B is translated by the vector -3, -2 to make shape C. Describe the single transformation. Now, if we're moving it 4 to the right and 7 down, and then 3 to the left and 2 down, they're basically saying what's happening to it overall. So it's still going to be a translation, still going to be translated by the vector. Now we need to do 4 minus 7, and then we need to add on -3 minus 2, and overall we're going to get 1. We've gone 4 to the right and then 3 left, and we're going to go down 7 and down 2, so overall down 9. So our final answer, translation by the vector 1 minus 9. Okay, 64 to the power of -2/3. Now I'm going to write this slightly bigger so it's a bit easier to see. 64 to the power of -2/3. Now you've got three things to do here. Firstly, a negative power makes the base number its reciprocal. So the first thing we're going to do is rewrite this as 1 over 64. Okay, 1 over 64, the base number, this number here, becomes its reciprocal. The reciprocal of 4 is a quarter. The reciprocal of 3 is a third. The reciprocal of 5 is a fifth. The reciprocal of 2 over 3 is 3 over 2. So that's the reciprocal. We've done that first. And we still need to do the power of 2/3. Now with a power that's a fraction, we root by the bottom number, and then we do the power of the top number. So we're going to do the cube root because it's a 3, and then we're going to square. So the cube root of 1 is 1, and the cube root of 64 is 4, because 4 times 4 times 4 is 64. And then we still need to square that. 1 squared is 1, and 4 squared is 16. So our answer is 1 over 16. In a sale, the price of a jacket is reduced. Jacket has a normal price of £52, and the jacket has a sale price of £41.60. Work out the percentage reduction in the price of the jacket. So any percentage that we're being asked, we're going to do the change over the original times by 100. If we're being asked for a percentage increase or a decrease, or asked what the profit is, it's the change over the original times by 100. So first let's work out the change. £52 take away £41.60 is £10.40. So it's going to be the change over the original times by 100 to get it as a percentage. Okay, and this is not very nice at all, but if we recognise that actually this is just a fifth, it's actually 5 times smaller, so we've got £5.20 would be 10%, and so 20% would be £10.40. So this is 0.2 times by 100, which is 20%. Okay, with recurring decimals to fractions, we're going to start by saying let x equal 0.624242424. So we're showing that we understand what that recurring symbol means. The first dot and the last dot show the bit that repeats, so we just get the 242424. Now the number of things that are repeating, which in this case is 2 different digits, tells you what to multiply by. I need to shift this over twice to line up the 2's and line up the 4's. So I'm going to go with 100x, and I'm going to try and squeeze this in to line it up really clearly for you. 424242424. The reason we do this is because we want it all to cancel out. So I'm going to turn it into a big sum, and I'm going to subtract bottom, take away the top. So that gives me 99x, and then I've got 62.4, take away 0.6, which is 61.8. And then the 2 take away the 2 is gone, 4 take away the 4 is gone, 2 take away the 2, and so on. These guys are just going to cancel out. So I've got 99x equals 61.8, and so x is 61.8 over 99, which is 618 over 990. It says we have to write it in its simplest form, and I'm looking at these thinking this is definitely the 3 times table, if not the 6 times table. I'm going to go ahead and divide by 6. So 618 divided by 6 is 103, and 990 divided by 6, once remainder 3, 6 remainder 3, 5 over 165. 103 is a prime number, so that is it. You are done. M is the point such B to M, M to C is 1 part to 2 part. So you might want to go ahead and write that this is a third and this is 2/3 because it's out of 3. Here's Charlie's method to find B to M in terms of A and B. Now we don't have this vector going from B to C, but we can go round. So he said that B to C, and he's absolutely right, is B to A and then A to C, and I agree with what he's written there. We can go from B to A and A to C, and that's the same as going from B to C. So he said, yeah, minus B, we get the minus when we go against the arrow, so he's right with that. He said that this bit is minus B, and then he's gone with the arrow here and he said that that's A, and I agree. So I would say, yeah, B to C can definitely be written by minus B add A. He's then said B to M is a half of B to C. Now, problem being is that it's not halfway. We were told that this was 1 part and this is 2 parts. We were told that this is 1/3 and 2/3. So if we wanted to get from B to M, we actually need to do a third of B to C, which would be a third of M minus B add A, or A minus B. Either of those, it's the same thing, the B is still negative. So evaluate Charlie's method. So Charlie has not realised that B to M is actually a third of B to C rather than a half. That's it. Okay, bottom part. Martin expands these brackets. He gets this. Explain why his solution cannot be correct. Now, that looks horrendous, and I know a lot of you would probably do it and then say why it's not correct and just tell me what the correct answer is. Now there's a bit of a clue here, it's only worth a mark, so there must be a quicker way. And there's a couple of things that we can check immediately. This term here is got by doing this times this times this. So 2x times 2x times 3x is 12x cubed, and that's correct. This constant term on the end is got by doing positive 1 times minus 3 times positive 2. So 1 times minus 3 times 2 is minus 6. So the constant term should be negative. Now there's a lot of other terms here that are got by lots of other ways. So you get the 1 times the 2x and all sorts of things that happen when you expand this out. But that term is pretty easy to check. It's just going to be that number times that number times that number, all your constant terms. And since that should be negative, we know that it's definitely wrong. The diagram shows the first 10 sides of a spiral pattern. It also gives the lengths in centimetres of the first 5 sides. The lengths in centimetres of the sides of a spiral form a sequence. So it's kind of kind. They've let us know that we're looking at a sequence here. Find an expression in terms of n for the length in centimetres of the nth side. So I'm kind of going to ignore this and just write out the sequence. So 1.5, 3, 5.5, 9, 13.5, and then so on. So we've gone up by 1.5, then we've gone up by 2.5, then we've gone up by 3.5, then we've gone up by 4.5, and I can only assume that we'd go up by 5.5 after. Oh, you can't see that, sorry, there we go. Now, if the difference is not the same, then we're going to assume that this is a quadratic sequence. Okay, so we need to go to the second difference, and this is add 1, this is add 1, this is add 1, this is add 1. Now with a quadratic nth term, we always go to the second difference, and that should be the same, and if it isn't, we've done something wrong, we need to go back and have a look. Okay, now we always half this number. If it was 2, we'd write 1n squared. If it was 4, we'd write 2n squared. If it was 6, we'd write 3n squared. If it's 1, we're actually going to do a half n squared. Let's start by saying what n squared would be. 1 squared is 1. So a half of that is 0.5. Now you might feel more comfortable doing it in fractions, but because they've done it in decimals, I'm going to stick to decimals. 2 squared is 4, and a half of that is 2, so that goes there. 3 squared, the third position, is 9, and a half of that is 4.5. 4 squared is 16, and a half of that is 8. And 5 squared is 25, and half of that is 12.5. So this is the sequence a half n squared, and that's going to get us some of the way. What more do we need? Well, we need an extra 1. 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 And we need an extra 1. So hopefully you can see that the nth term of this is going to be a half n squared add an extra 1. Solve algebraically. So here we have the equation of a circle. Equation of a circle is x squared add y squared is the radius squared. If we were ever asked for the radius of the circle, it would be the square root of 18 or 3 root 2, depending on how you did it. And then we've got a straight line here. You can see we've got no powers, so it's going to be a straight line. What we want to do is make either x or y the subject of the linear equation. I'm going to go ahead and make x the subject just because minus 2y, it's easy to get that onto the other side by adding. So first thing I'm going to do is write x equals 2y minus 3. I've added 2y to this side, and I've added 2y to this side to get a linear term, but with x as the subject. And I can now go ahead and find out what x squared is. So x squared is going to be 2y minus 3 all squared, and to do that I need to write it out twice. 2y times 2y is 4y squared, minus 6y, minus 6y, add 9. So 4y squared minus 12y, add 9, and that is what x squared is. We can now put that in to here. So instead of writing x squared, I can now write this. So I'm going to write 4y squared minus 12y, add 9. That's my x squared. Add y squared equals 18. So I've changed the x squared to be this, because that's what x squared is. And we can now collect together all our like terms, and because it's making a quadratic, we need to make it equal 0 as well. So I've got 5y squared minus 12y, and then going to take 18 away from both sides, so I get minus 9 equals 0. Okay, taking away from there. I'm then going to factorise it. They didn't tell me to round my answers, so it's a bit of a clue that it should work. It's going to be 5y and y, and most likely 3 and 3, but let's just double check. So yeah, I've got 15 from there and 3 from there, and that's going to enable me to make minus 12. I'm going to have minus 15y, add 3y, and so my solutions are whatever makes this bracket equal 0, which is 3, and whatever makes this bracket equal 0. If 5y add 3 equals 0, then 5y equals minus 3, and y is minus 3 over 5. So I've now got one y value and the other. We now just need to substitute that back in. We know, we wrote it at the top, up here, that x is 2 lots of y, take away 3. I'm going to call this one y number 1, and I'm going to call this one y number 2. So when y is minus 3/5, I know that x is 2y, take away 3. I got that from the top. So I'm going to do 2 lots of this. Let's keep it. Let's write minus. So this is also minus 0.6. That makes it a little bit easier. Double that is minus 1.2. Take away 3 is minus 4.2. So when x1 is minus 4.2, y1 is minus 0.6, and then when x2 and y2. So now looking at our other value, we need to do 2 times 3, which is 6, take away 3 is 3. So 3 and 3, and they actually are the same on those. What we've actually done is found out where the straight line crosses the circle, and we've got 2 different coordinates. These two go together, minus 4.2 minus 0.6, and these two go together, so 3, 3. Just like that. So you found where they cross, and actually any simultaneous equations are actually just enable you to find where things intersect on a graph. Okay, transformations of functions. The graph y equals f of x is shown on the grid. Graph A is a reflection of the graph y equals f of x. Write down the equation of graph A. So if we started with f of x and we've reflected it in the y-axis, then we'd say that that's y equals f of minus x. Okay, f of minus x reflects in the y-axis, minus f of x reflects in the x-axis. It's worth knowing the difference between those. For the second part, graph B, which is the higher one, is a translation of the lower one, g of x. What have we done? Well, it's actually just moved up one, and we would say y equals g of x, add 1. Okay, the graph of y equals cos of x is shown. Write down the coordinates of the point marked C. Now, cos goes from 1 down to minus 1, and it repeats over 360 degrees. I like to remember that cos is a cup, and sine is an S. That sounds silly just saying it like that, but cos is like this, a cup, and sine is an S. And obviously they go on for much longer. There you go. Cos is a cup, so cos is that one, and sine is an S. Makes sense to me. And that's what they look like. They both go from 1 to minus 1, and they repeat over 360 degrees. And of course, if they're transformed, they can do different things, but generally they go from 0 to 360, and then they keep repeating and repeating, and that's how we get a wave. So I know that this is 360, so I know that this is going to be 180, we have 90 here, and we have 270 here. So this coordinate here would be 180 across and down to minus 1. Okay, there are 6 black counters and 4 white counters in bag A, 7 and 3 in bag B, 5 and 5 in bag C. Bernie's going to take at random a counter from bag A and put it in B, and then he's going to take at random a counter from B and put it in C. What's the probability there are now more black counters than white? So I'm going to do this as a tree diagram, and I'm going to show you what can happen from bag A firstly. So this is going to be bag A. What can he take out? So from bag A, there are 6 black counters. Let's put black up here and white down here. So his probability of taking black is 6 out of 10, and his probability of taking white is 4 out of 10. That's the first thing that can happen. Okay, and then we're going to put that into bag B. Now, if this is bag B, if I've put a black one into bag B, there were 7 and 3. But if I'm coming up this pathway, that would indicate that there's now an extra black one in bag B. So that's going to be 8 black counters out of 11 and 3 white counters out of 11. This is black, this is white. And similarly down here, this is still going to be bag B, but this is the other alternative version. We've got black and we've got white. Now, if I come down this pathway, I'm going to have an extra white one. So 4 out of 11 and 7 out of 11. In that bag B, I had 7 and 3, but if I've come down this pathway, I've now got 7 and 4. So this is bag B, and then I'm going to take one of those. Now, if at the minute in bag C there's 5 black and 5 white, so if I end up here having taken a black one out of bag B, then there's then going to be more black than white. If I take a white one, there's going to be more white than black. If I take a black one, there's more black than white. And if I take a white one, there's more white than black. So this is telling me what's going into bag C. I want the probability that there are now more black counters, so I want this one and I want this one. I want the probability of this happening, because if I select a black one from bag A and then a black one from bag B, or if I select a white one from bag A and then a black one from bag B, those are the options where my C bag is going to have got more black counters in it. So the probability, we times along the branches and we add the ones we want. So in that case it's going to be these, timesing fractions, top times top and bottom times bottom, and altogether that's going to make 76 out of 110, and that's my final answer for the chance of that happening.